Unit 7, all about equilibrium in KSP. These are the practice problems that we came up with. Let's see how we worked them out. Number 1 is a common ion question. The molarity of each one of the solutions is the same. So let's look at A and figure out what effect will it have. For a 0.01 molar solution, since there are 3 sulfates, it will be 0.03 molar for sulfate. For letter B, since there's only 1 sulfate, it'll still be 0.01 molar of sulfate. C will be the same. And then for D, you've got 0.01 molar of barium. The choice that will give the most common ion will have the greatest effect on solubility, and that would be letter A, because there's more sulfate in solution, and that will affect how much of it can dissolve. Number 2 is a Le Chatelier question. A copper nitrate solution gives off the copper 2 ions, causing it to be light blue. When concentrated ammonia is added, it causes a shift to the right and makes it deep blue. So the correct answer there is C. Number 3 is also a Le Chatelier question. We know that the equation goes from 2 molecules of gas to 2 molecules of gas. We also know that the delta H is greater than 0, which means it's endothermic. So we just need to decide out of 1, 2, and 3, which one will cause the quantity of HI, in other words, a shift to the right, to increase. Adding H2, since you're adding a reactant, it will cause more HI to form. Roman numeral 2, increasing the temperature. Since it's endothermic, we know that energy is a reactant. Adding a reactant increases the amount of product, which in this case is HI, so increasing the temperature would also cause an increase in HI. So far, both Roman numeral 1 and 2 are correct. Decreasing the pressure. If you decrease the pressure, it favors the side with more gas molecules. But since there's 2 molecules of gas on the left and 2 molecules of gas on the right, then pressure will have no effect on the equilibrium. So the correct answer is Roman numeral 1 and Roman numeral 2 only. Number 4, first we need to write the equilibrium expression, and then we'll plug in the numbers. When we do that, we get 4 cubed over 2 squared times 0.5. Your students should be able to do this math without a calculator. Number 5 is how would you write the appropriate equilibrium expression? Well, there's 2 HIs, so it would be products over reactants, HI squared over hydrogen and iodine on the bottom. And the only one that looks like that is letter D. Number 6 also references the equation up above. We have to figure out which statement is false. If it's heated, the right side is favored. Well, we know that the delta H is greater than 0. It's endothermic. So if it's heated, the right side is favored. That's true, because heat is a reactant in an endothermic reaction. Removing HI as it forms forces the equilibrium to the right. Removing a product shifts the equilibrium to that same side, so removing product would cause a shift in equilibrium to the right. That is also true. If the volume of the reaction container is changed, neither the reactants or products are favored. This is also true because there's 2 moles of gas on the left and 2 moles of gas on the right, so changing the volume would change the pressure and it would have no effect on this particular equation. Adding more H2 increases the equilibrium constant. We know that that cannot be true because the only thing that changes the equilibrium constant would be a change in temperature. This again is taking the equation as written and making sure it's products over reactants, and the products get the coefficient as an exponent. So it would be W cubed times V over X squared times Y. Number 8 is a gas equilibrium question. If the volume is increased, then the pressure has to go down. So what will the effect of lowering the pressure do on each one of the answer choices? An increase in pressure causes a shift in favor of the side with fewer gas molecules. So a decrease in pressure will cause a shift to the side with more gas molecules. In letter A, you go from 1 gas molecule on the left to 2 gas molecules on the right. So a decrease in pressure would cause a shift towards the right. For letter B, notice that there's more gas molecules on the left than on the right. So a decrease in pressure would actually favor the left-hand side, the reactant side. Letter C, there's an equal number of gas molecules both on the left and the right, so changing the pressure will have no effect. And in letter D, there's more gas molecules on the left than on the right. Notice that carbon is a solid. So there's 2 gas molecules on the left, 1 on the right. So we would pick the choice that has more gas molecules on the right in products than there were in reactants on the left. Number 9 is a Q versus K question. So the Q expression is going to be HI squared over H2 times I2. So pick any number. I'll pick 3. 3 moles over 3 liters means it's 1 molar. 1 squared over 1 times 1 is 1. No matter what number you pick, for the number of moles, you will always get a Q value of 1. So since Q is 1 and K is 50, Q is less than K. When Q is less than K, the reaction will shift to the right to make more product until Q becomes equal to K and you reach equilibrium. The other thing to remind students about is to flip these expressions around and make it when K is greater than Q, so that when you start with K, the arrow points the way. And if you write down K is greater than Q, the arrow points to the right and it will shift to the right. So between B and C, which match up with Q less than K, we want a shift to the right and more HI will be produced. So the correct answer is C. Number 10 is also a Q versus K question. This one's a little bit tougher, but notice that the K value here is incredibly small, 1.8 times 10 to the negative 56. So all we have to do is come up with a Q expression and plug in our numbers. And when I do that math, I get 1,838 with a calculator. Even without having a calculator, your students should be able to plug in those numbers and know that whatever value they get will be much larger than 1.8 times 10 to the negative 56th. It's okay if they don't use a calculator on this, but they should know that 2.5 squared over a very small number cubed should be a number greater than 1. They should be able to do that math. So since Q in this case is greater than K, then the correct answer will be either C or D. Since Q is greater than K, turn it around and K is less than Q, and when you start with K, the arrow points the way. Since K is less than Q, it'll shift to the left, and Q will get smaller and smaller and smaller until Q is equal to K and equilibrium is reached. So this is a shift to the left towards reactants, which means the amount of O3 should go down and the amount of O2 should go up. This is a combination of an equilibrium problem and a little bit of stoichiometry. If you only have reactants going in, then at the end, you're going to have to turn some of those reactants into products. We know that the K value is greater than 1. In fact, it's 1500. A K value of 1500 means products are really favored and reactants not so much. So if you start with 2 moles of CO and 2 moles of H2O, notice in the balanced equation, the coefficients are 1. So however much of CO you use up, you will use up the same amount of H2O. So at the very end, at equilibrium, since you started with the same amount and they would go down by the same amount, the amount of CO and H2O should be equal. And since CO2 and H2 are products and K is so large, we would expect that CO2 and H2 would be larger than the amount of CO and H2O. So we're looking for an answer where CO and H2O are the same, or an answer where CO2 and H2 are the same, or an answer where CO2 is greater than the concentration of either one of the reactants. And the only answer that looks like that is letter C. Number 12 is just a Le Chatelier problem. Typically we say that adding water to a situation like this has no effect. However, since water is actually involved in the formation of the complex ion that turns it pink, then we would have to consider here that adding water will actually have an effect. So if we add water, and water is a product, then we would expect that adding water to it will cause a shift from the blue side of the equation to the left-hand side of the equation, a shift to reactants causing it to go pink. Since pink isn't an option, we would then look at what else is in the reactant side and notice that more chloride ions get made. So the correct answer choice would be A, more chloride ions would be produced. All the other choices basically say a shift towards the right, towards products. Number 13 references the same equation up top. If you add silver nitrate, notice silver nor nitrate are actually in the equation. So what would silver do to the equation? Well, silver chloride is extremely insoluble. So since you would be adding silver nitrate to it, the silver would bind to the chloride and it would precipitate out. So effectively, the silver would remove chloride ions from solution. If you remove something from one side, it shifts towards that same side. So if you took away chloride ions, then it would become more pink. Number 14 and 15 also have to do with this same equation. If we add hydrochloric acid at 6 molar, we're really adding an awful lot of hydrogen ion and chloride ion. The only thing in the equation is the chloride ion. So adding a chloride ion to the left-hand side would cause a shift to the right towards products, going from pink towards blue. The only answer choice that matches up with that shift to the right is letter choice D. The pH of the reaction would actually decrease because you're adding more acid. Becoming more pink would be a shift towards reactants, and C says shift towards reactants. We know that it will shift to the right towards products. In number 15, if you added oxygen to it, notice that oxygen is not present in the equation, and that oxygen is really not going to react with any of the species listed. So oxygen would not affect the equilibrium of the reaction. Number 17 is all about the effect of temperature on the value for K. This reinforces the idea that temperature actually has an effect on the equilibrium constant. So when you get warmer, when you go from 25 degrees to 50 degrees, notice that the value of K actually gets larger. You go from 10 to the negative third to 10 to the negative 1. Since K is getting larger, that means when you heated something up that you produced more products. The larger the value of K, the more that products are favored. So an increase in temperature causes an increase in value of K, which means an increase in the amount of product. That means that the reaction has to be endothermic. If it had been exothermic, an increase of temperature would mean that the heat generated by an exothermic reaction would be on the right-hand side, a product, and an increase in temperature would cause a shift back to the left. And that would actually make the value of K get smaller, not larger. This is a similar question to the one before. K at 25 degrees is 4 times 10 to the 8th. We know that it's exothermic because delta H has a negative value. That means that the reaction is exothermic, that heat appears on the right-hand side of the equation. So if you increase the temperature, then you are adding a product, and when you add a product, it shifts to the left. So that means we should create more reactants, and the amount of product should go down. A would not be right because K should get smaller. We're creating more reactant. Letter B should not be right because that sounds more like you're producing more products. And we know that an increase in temperature is going to cause a shift towards reactants. So a shift to the left means the answer is C, because we know that an increase in temperature will cause a shift to the left. If you add X, then that will cause a shift to the right, meaning you're going to use up some of the X and you're going to use up some of the H2, and you'll create the product H2X. So adding X will cause the H2 to go down. We don't know how much X2 was added, so overall we don't know what will happen to the concentration of X2. All we know is we added some. So it's possible that equilibrium, the X2 is actually larger than it was before. 20 is a classic question about what happens if you add an inert gas. If you add argon to the above equilibrium, it will cause no change whatsoever in equilibrium. so will have no effect. If you decrease the volume and increase the pressure, that's going to favor the side with fewer gas molecules. So you can see that there's 3 gas molecules on the left in number 21 and only 2 on the right. So increasing the pressure will cause a shift to the right and more H2X will be produced. Since energy is a product and this reaction is exothermic, then increasing a temperature will cause this reaction to shift back towards reactants, and more X2 and H2 will be made. Letter C is wrong because it's impossible to make only H2 and not X2. If you're going to make some of the H2, then you've got to make some of the X2 as well. We want the 2 equations here to add up to the target equation down here. The first equation we're going to actually keep, but we're going to have to multiply it through by 1/2. When you multiply an equation through by 1/2, you take the original k value and you make it go to the 1/2 power. The second equation, we want to flip it, causing the CuO to be on the right-hand side, because in the target equation, CuO is on the right-hand side. We don't have to multiply it by anything. When you flip an equation, the new k becomes the inverse of the old k. So once you flip it for the second equation, it'd be 1/K2. Once you have them all lined up and ready to add together, when you add 2 equations, you multiply together the 2 k values. So the first one was k1 to the 1/2 power times 1/K2. And the only answer choice that matches up with that would be C. A good example of a whole lot of reading and you don't really need all the information. They give you a KSP value for silver nitrate. It's very high, it's very soluble. They give you a KSP value for AgL that's very low. We know not very soluble at all. If the choice was made to create a silver ion solution using silver nitrate, which one would cause an increase in silver concentration? This just becomes a matter of which one added to it will cause the silver ion to decrease. The correct answer here is B. Nitrate ion would not actually have an effect because it's just a spectator. The chloride ion, however, would cause a precipitate to form. KSP value for silver chloride is so low that it is not very soluble at all and thus will precipitate out. Hydrogen ion will have no effect because the hydrogen ion plays no part in the equilibrium. It's really just silver ions and nitrate ions, and adding those hydrogen ions won't do anything to it. Nitric acid is a strong acid and will stay apart as ions. So adding nitrate will not cause the hydrogen ions to glom on and take hydrogen ions out of solution. It's a strong acid. Adding a solid doesn't affect equilibrium. The silver is just going to sit there. It's not going to affect how much silver ion is in solution. 25 looks like a really hard math problem, but this should be something that your students ought to be able to do without aid of a calculator. First, we have to set up the KSP expression. The fluoride ion gets squared because there will be 2 fluoride ions for every 1 lead ion. When we divide 4 times 10 to the negative 8th by 1 times 10 to the negative 6th, we should get 4 times 10 to the negative 2nd. The other way to write that out would be 0.04. Your students should be able to take the square root of 0.04, and that will give them a fluoride ion concentration of 0.2 molar. Since it's 1 liter of saturated solution and it's 0.2 molar, you should need 0.2 moles of NaF added to give you 0.2 moles of fluoride ion in 1 liter of solution. Number 26, this time they're telling you what the solubility is and asking you to find KSP. So first we write the expression. We know that both copper ion and iodide ion will be 2 times 10 to the negative 6th, which means KSP is equal to 2 times 10 to the negative 6 squared. And again, this can be done without aid of a calculator. To do number 27, first we need to write out the KSP expression for silver chromate. We know for every 1 chromate there will be 2 silvers. So we substitute in X for chromate and 2X for silver. We do the math, divide by 4, and X cubed will be equal to 2 times 10 to the negative 12th. we need to find the answer choice that matches up with the cube root of 2 times 10 to the negative 12th. And that correct answer would be D. For number 28, the equilibrium constant is 2 times 10 to the 5th. So what is the value of k for the reverse? That would be 1 over the old k. So 1 over 2 times 10 to the 5th. And that would be 1 over 2, which is 0.5, and 1 over 10 to the 5th, which is 10 to the negative 5th. So you get 0.5 times 10 to the negative 5th. And that's the same thing as 5 times 10 to the negative 6th. For number 29, we know that the OH is 2 times 10 to the negative 6th. Looking at the equation of dissolution, we know for every 1 zinc, there's going to be twice as many OH ions. So if OH is 2 times 10 to the negative 6th, then zinc is 1 times 10 to the negative 6th. The KSP expression is going to be the concentration of zinc, 1 times 10 to the negative 6th, times the concentration of hydroxide squared, because there's 2 hydroxides. So it's really 1 times 10 to the negative 6th times 2 times 10 to the negative 6 squared. So 1 times 2 squared is 4. 10 to the negative 6th times 10 to the negative 6 squared is 10 to the negative 18th. So we're looking for an answer that is 4 times 10 to the negative 18th. Number 30, this is a Q versus K. So first we have to write the Q expression. We plug in the numbers given to us about how many moles are in a 1 liter container. And we do the simplified math. And without having to go through and do all the math, realize you have 2.5, a number larger than 1, divided by a very, very small number. When you do this math, you're going to get 2.5 million. Even though K is fairly large at 1.6 times 10 to the 4th, the Q value is larger. And since Q is greater than K, then the answer choice has to either be C or D. When Q is greater than K, that means there's way too many products and it will shift to the left. A lot of reading, but it comes down to this is a saturated solution. Some solid still remains. So this is a solution in equilibrium. If you added some chloride ions and some hydrogen ions, because it's concentrated hydrochloric acid, what would happen? Well, notice that chloride is nowhere in this equation, so the chloride would have no effect. However, the hydrogen ion would react with the OH ions and decrease the hydroxide ion concentration, effectively taking away a product. And when you take away a product, it's a shift to the right. A shift to the right in this case is that the solid would dissolve some more. So the correct answer would be C. Number 32 is just a Q versus K. So the first thing we need to find is what is the value of Q for each one of these choices. And so we write the Q expression. Then we just need to plug each answer choice, A through D, into the Q expression and calculate those numbers. This is how you would do the first one. 0.3 squared over 0.6 times 0.6. When you do it for each one, A through D, you get these answer choices. And if we want the formation of more reactant, that means we want to shift to the left. So notice that all these answer choices are set up where K is less than or greater than or equal to Q, because when you start with K, the arrow points the way. So we want the one where the arrow points to the left. The only one with the arrow pointing to the left is A, and that would cause formation of more reactant. Number 33 is a definite calculator problem. This is not something you can do in your head. First we write the K expression, then we substitute in the KSP value, and we solve for X, and you get 0.0144.